Hello everyone, welcome to our paper presentation, an application for validation of power distribution system models in an ADMS environment. I'm Siva Paudel and I am a power systems engineer at Pacific Northwest National Lab. As we know, the power distribution systems are evolving in nature and several model-based applications such as volt-var optimization, state estimations can be developed for planning and operation. However, if the models are inaccurate, then the decisions made by those model-based algorithms might be invalid. And the distribution system models are error-prone because of several reasons, such as evolving nature of systems, delays in model updates, and model validation is challenging due to those factors. So the motivation behind this work is we need a framework for comprehensive network equipment model validation. This slide shows the methodology. And the slide on the left, it shows the block diagram, which explains the relationship between different models such as network equipment model, which consists of several elemental information, equipment state, and the measurement model. So the comprehensive model validation requires check for both model consistency and model feasibility. And model validation refers to verifying the accuracy of the elemental information used to assemble the models. For example, if we want to validate network equipment model, then we can validate this elemental information separately. So there can be separate modules for each element. So building on that, we implemented the proposed model validation framework using the modular architecture of the GridFT platform. And the figure on the right here shows how the model validation fits into the ADMS environment. So the two different models available for validation are the SIEM XML model and the measurement model, which is driven by a distribution system simulator such as OpenDSS or GridLabT. And there can be several modules in our model validation application. So the bidirectional flow between the database and our application suggests that not only we query the model information, we also update the model if some inconsistencies are found. And this slide right here shows the results. So first we have proposed a validation index metric that shows how many candidates are valid for a given specific module. And once the validation index for different modules are evaluated, if there are S number of modules, then the final validation index would be function of different validation index on a module basis. In addition to validation index, we also evaluate the percentage loading of different component. So the percentage loading is just the ratio of what is the current status or what's the current flow versus what's the rating of the equipment. And based on that, we also reported the health rating of different equipment. So this table right here shows the three different report. The first one for the service transformer, second one for the line segment, and third one for the topology validation for three different test cases. And the validation index is shown in the second column right here. And the loading of the service transformer is represented in terms of mean, max, and average. And the health of the transformer is categorized into three different ratings based on percentage loading. And similarly for the line segment. So there is mean, max, and average line loading and number of equipment that falls under different health ratings and the corresponding validation index metric using this same equation. Similarly for the topology validation, the validation index metric is shown here. We extract the information like static loops in the system, if there are any isolated network, and then if there is a loop, then what is the average number of switches in a loop? So those kind of things are reported in the topology validation report. So to conclude, in this work, we have proposed a framework for comprehensive network equipment model validation. And the pre-release version of this application is available in this website. Feel free to check this out. And we have demonstrated the function using the GridFT environment. And the proposed application has a modular architecture that allows user for easy plugin of the new functionality. And in future, we plan to derive and validate the entire system admittance metrics from SIM model. And in addition, we are also planning to work towards mapping and validation of SIM RDF schema using SACL profiles. Thanks for your time. That's all.